all. Happy National Science Day once again. Thank you, and let's make today's seminar a truly enriching experience for all. Thank you.
Thank you, sir. Let us introduce our chief guest, Dr. K. Vijaykumar, currently working as a professor in the Department of Biomedical Engineering, Dr. NGP Institute of Technology, Coimbatore, India. He has completed his UG degree in Electrical Electronics Engineering at Kongu Engineering College, Erode, in the year of 2001, and PG degree in Process Control and Instrumentation at Annamalai University, Chidambaram, in the year of 2004. He has completed his PhD in Non-Linear Control in the year of 2015 under Anna University. He has 20 years of teaching experience, in which he has previous work experience at Dr. Mahalingam College of Engineering and Technology during 2004 to 2023. His field of interest includes biomedical instrumentation, nonlinear control systems, and soft computing techniques. Next, we have the privilege of hearing from our esteemed guests who will share their valuable insight. First, I would like to invite our chief guest, Dr. K. Vijaykumar sir, to give away the guest address.
Thank you, madam. Am I audible?
Yes, sir, audible, sir. Thank you, sir.
Okay. First and foremost, I thank the management principal and head of the department for having given me the great opportunity to present the recent technology, emerging sensor technologies on this auspicious day, because we are celebrating National Science Day today. So thank you all for having given me this great opportunity. So with this introduction, I'm moving to the presentation. So today we are going to discuss about sensor and its applications. Whether the slide is changing or
Slide is not changing, sir.
yes, just I'll check. It's changing now.
Change it, sir. Change it.
Yes. So emerging sensor technology, we know that actually the evolution of sensors actually transforming the engineering into the next phase. So we are now live with a lot of sensors. There are so many sensors like IoT enabled sensors, smart sensors, wearable sensors, AI enabled sensors, and biometric sensors. AR and VR actually plays a vital role in place of actually all domains of engineering. And we know that the recent transmission, the communication side sensors. So if you look at the smart sensors, now everybody talks about smart devices, that is IoT based sensors. IoT, it's actually Internet of Things, and there is one more term called Industrial Internet of Things, IIoT, and we know that there is an evolution recently going on, like Industry 5.0. Earlier we were talking about Industry 4.0, industrial revolutions. So now all are actually talking about Industry 5.0. In Industry 5.0 as well as 4.0, IoT-enabled sensors plays a vital role. All sensors now comes with IoT, and we can actually get any data from any places. Remote side, you can operate your device as well as you get the data from remote. And also you can do any kind of analysis. Even we can send signal to the your manipulated devices like your valves and other things, because every device now come with IoT. And coming to the wearable devices, that is wearable sensors, we are now again talking about smartness in healthcare industry. So healthcare industry is the biggest industry nowadays. It's growing like anything. Even getting an appointment in the topmost executive and doctor, and you are not actually waiting in the queue. You can even get appointment from your place, and you can visit doctor, and you can even get connect with the doctor globally, and you can get any kind of treatment globally. These are all now possible. And coming to the wearable sensor side, so now we have all kind of sensors, kind of wearable things. So we can wear sensors in our body, and you can take any kind of data from our body. Even there are two types, invasive and invasive type. So you can actually place on the body as well as inside the body. And the AI-enabled sensors, it is again another interesting domain. Anyway, I'm going to discuss each and every sensors with few examples. And these are all some of the recent technologies we have actually day-to-day life we have seen and we have come across, like smartwatch. Everyone actually using smartwatch. We know that smartwatch actually senses our heart rate actually and blood pressure, and even some of the devices come with actually our glucose measurement as well. So we know that how glucometer works. Recent instruments are working based on the enzymes coated with the strip, and that strip actually get some samples, like blood sample is placed in the strip. It will get oxidized, so we'll get a ferrocyanide at the end. So after getting ferrocyanide, if you look at the device, you pass through the current through the strip, and the amount of current passed through the ferrocyanide is your glucose level measurement. So glucose level measurement is in terms of milligram per deciliter. So DL, mg per DL, it is the measurement unit. So the ferrocyanide actually interacted with the enzyme glucose oxide. That is the basic principle. So nowadays the strip size is the major part. Students can work on the strip size, and also students can also think of the device miniaturing and device effectiveness, and the also the correctness in the reading. These are all the areas we can work. Our students can work and develop something. And the second part is actually doorbells with camera. All these smartphones nowadays actually come with doorbells with camera. So if you look at the safety side and security part, all the now the doorbells are come with video cameras. So you can actually go with the biometric kind of sensors. If you look at the biometric sensors, there are several measurement can be included, like thumb impression and your facial recognition. Even for iris recognition, you can actually recognize eyeballs, iris recognition. If it is matched, then you can allow them inside. So this kind of devices, not only for smartphone, you can actually use it wherever we need actually security part. And the third actually picture representing the agriculture, smart agriculture. Now again, everybody talking about agriculture is the only thing which is going to actually decide the future. So even the engineers definitely take some role in the agriculture, smart agriculture side. So you can go with some of the sensors like moisture sensors, and we can actually automate irrigation systems. And you can monitor your farm from the global side, where you can sit in one place and you can monitor your farm, and actually you can do many things in the farm from the remote place. So if you look at one sensor, moisture sensor, we know that the moisture sensor works based on the capacitive type. So you have two legs, and the permittivity, actually water here in moisture sensor act as a permittivity medium. So we know that capacitance is equal to epsilon A by D. If permittivity varies, we know that capacitance varies. So through which we can take measurement of moisture. Similarly, there are so many sensors used in farming. Even some of the sensors like vision systems. Vision systems can actually inspect the growing or plant growing and even the farming of plant. So they take pictures of leaves and compare with the leaves with for the better understanding and do analysis. And based on the analysis, we can go for fertilizing things and all these things, irrigation as well. We can do from the analysis. And the remaining pictures are actually based out of temperature measurement and based out of flow measurement. And the air purifier, again, another one important device, because now we are living in a world called actually all kind of emission we are taking, and it's kind of air pollution. We know that our capital city actually highly polluted with the carbon dioxide emission. So everybody needs now this air purifier kind of things, and this air purifier actually takes the reading of particles in matters, which is actually denoted in PM10, PM2.5. Likewise, PM10 means it is not inhalable, so you can up to, it's actually micro nanometer kind of things. So we can inhale up to 2.5 PM. So those things can be measured through air purifier device. And another device is detection of movement, motion sensor. We know that the passive infrared PIR sensor actually plays a vital role in PIR in motion kind of things. It is again for security purpose as well as the industries used in the production line, so they can actually sense and also some of the movements. If you want to identify, then we can go with passive infrared sensors. And another thing is proximity sensor. The last and previous picture actually representing proximity sensor. Proximity sensor actually used to detect the objects, and based on that we can actually choose the lane. And we know that now every car actually in automotive sector we have actually fully automated car, and we are talking about autonomous car. Autonomous car means then it should learn automatically, and it should travel that lane. And if something obstacle or something comes in suddenly, then accordingly the decision need to be taken. All these things plays now a vital role, and these are all challenges still are we are facing. So students can work on actually autonomous car as well as so then suppose if you want to work on the autonomous car, then you will be you should be very familiar with the radar, lidar, all these things, and all kind of sensors. So because nowadays sensor only placed our sensors are major part in the automotive sector. And the last part again, it's temperature measurement. And coming to the basic definition, we know that sensor is a device which is used to detect the change in the physical properties. So there are so many other definitions also. Here from our dictionaries, we are taking a sensor is a device that responds to physical stimulus and transmits the resulting impulse. So these are all from various dictionaries. So if you look at all the definitions, the very simple definition is it is a device that detects and measures physical properties or changes in the environment. So that may be converted after based out of our requirement. This is the basic definition of sensor. And coming to the difference between sensors and transducer, because when you look at the sensor, automatically you will get to know about transducer also. So and again, we'll get some confusion. What is sensor? What is transducer? Very simple comparison between sensor and transducer is sensor, which actually accept and detect the physical changes and gives output directly. Whereas transducer, which actually converts one form of energy to another form, which needs a conversion unit, that is signal conditioning unit inside. That's the basic difference between sensor and transducer. If you look at thermometer, that is mercury thermometer. It is actually as a sensor. It measures temperature and gives the output directly. Whereas if you look at thermistor or whatever, maybe other kind of temperature devices, those are all called transducers, because which converts one form, because it measures physical form temperature, but it gives actually electrical output. So it has a conversion unit inside. So we are getting electrical output outside. So this is the basic difference between sensor and transducer. Again, this is also same thing, sensor. And coming to the different types of sensors, we have touch sensor, ultrasonic sensors, light sensors. And basic category, there are two categories, analog and digital. So analog, it is used to actually continuous measurement. And these are all other types of sensors which we have actually come across on day-to-day basis: temperature, chemical, gyroscope, optical, gas, accelerometers, level, proximity, noise, motion, light, and moisture sensors. And coming to the types, there are different types based out of categories. So one is based on connection type, one is contact, another one is non-contact type. Based on power requirement, active sensors and passive sensors. Based on physical parameters, so that is measurable or the parameters which need to be measured is called physical parameters. So flow, pressure, level, temperature, so many other parameters also there. And so coming to the sensor classification based out of mode of operation, null type, deflection type, and based out of measurement, again it is acoustic. Biology. So there. Coming to the transducer output, electrical input, which gives actually physical parameter as the output. This is called inverse transducer. And we know that transconductance principle, based on the working principle, there are different types: resistive, capacitive, inductive. So do you have any doubt up to this, or I'm going fast, or some other thing, because these are all basic things. Students can maybe give me some input. Hello. Anything need to be discussed till then, or shall I proceed? Shall I proceed, ma'am?
Yes, sir. Yes, sir.
Okay. Okay. The slides are changing, or hello? Slides are changing or not? Actually? Oh, sorry. Madam, slide now. Types of transducer slide is appearing. It's appear, or
Yes, sir, appear.
It's changing now.
Yes, sir, changing.
Next slide. Actually, I'm moving to next slide. Is it okay? Yes, yes. So this is the difference between active and passive transducer. We know that active transducer means actually we have thermistor, strain gauge, capacitive, inductive sensors are active, and the passive thermocouples and piezoelectric type sensors are actually passive type. It is based out of actually the power requirement. We have two types, active and passive type. And some or other types, contact type and non-contact type. So suppose if you have physical contact, like strain gauge and all temperature sensors need to be placed at the physical parameter for the measurement. Non-contact type, it may be actually placed away from the physical parameters. So like the magnetic sensor, infrared type, optical type, all these comes under non-contact type. And absolute sensors and relative sensors. A sensor that reacts to the physical parameter is called absolute. Thermistor, strain gauge are actually directly react with the physical parameters. Whereas relative, it actually not directly relate with the physical parameters need to be measured, which actually gives or react with some other parameters. So indirectly, we can take the reading of the parameters which need to be measured. So that is the difference between absolute and relative. So coming to the level sensor, so based out of the types, I'm going to take only the level sensor for the discussion. So level sensor, there are two major categories. One is point level measurement, and another is continuous level measurement. So we know that point level measurement means which actually gives, it's like binary, which actually gives some of the types are binary, like float switch and the turning fork, all these things actually binary, which actually gives once the level is reached at the point, then it gives actually 1 or 0. Suppose it is like our overhead tank automation, we have used actually domestic water level controllers. So these controllers uses actually magnetic switches, that is float switches. So once level reaches, then the float switch closes, then you will get the output as 1. Accordingly, your action takes place. Similarly, turning fork, that is tuning fork, actually it gets vibrated once the level reaches, then accordingly output varies. The remaining things are capacitance and conductivity. So capacitance, again, we know that C equal to epsilon A by D. So this capacitance transducer actually placed inside the tank. If level rises, the distance between the plates or otherwise the area of the capacitance varies. So automatically we'll get change in capacitance. That will be act as a measurement. And conductivity type, we know that if the level reaches, then conductivity takes place between the rods. So automatically that will be act as a reading. So these are all point level measurements. And coming to the continuous level measurement, suppose if you want to monitor the level continuously, then we can go with the ultrasonic or radar kind of thing. So you can pass the ultrasonic wave into the liquid phase, and you can measure the wave reflection, and the time taken to reach the transmitter can be as a measurement. Similarly, for radar also used for the continuous level measurement. So these are all some of the level sensors, and here it is actually sensor kind of thing. There is no smartness in the sensors shown in the pictures. Actually, coming to the one applications, here I have given actually conical tank level measurement. So you can use either the capacitive type sensor here. You can place inside the tank and measure the change in level through the change in capacitance. Otherwise, we can go with the where here actually given DPT. What's DPT means? A differential pressure transmitter. You can actually take the pressure as a measurement through which we can measure the level. So if the change in level occurs, we know that in DPT there is a change in pressure. There are two sides actually. If you take differential pressure, means you should have two pressure. One pressure actually directly taking from the liquid level. Another one is atmospheric pressure. So the change in pressure is actually measured, and that will be converted into, in case of industrial standard, it is actually 4 to 20 milliamps. Normally, the current range is used in the process control industry is 4 to 20 milliamps, whereas for pressure range, actually industrial standard is 3 to 15 psi. If you look at this conical tank, the level is converted into 4 to 20 milliamps. 4 means the level is minimum, that is 0. 20 milliamps means the full level. So output is varies based out of the minimum level to full level. If the level changes, we'll get output accordingly between 4 and 20 milliamps. So through this differential pressure transmitter. So this will be given to the PC, and your personal computer is actually PC based control system. Your PC is actually calculating and compare with your desired level. And if the level is not up to the mark, that is not actually reaching the desired level, then accordingly you need to take some action. That action will be given to the input flow manipulation. So input flow manipulation here done through the control valve adjustment. We know that control valve is actually operated under pneumatic signal, so that this 4 to 20 milliamps need to be converted into pressure signal 3 to 15 psi. Then you need to have a I2P converter. So I2P converter converts this 4 to 20 milliamps into 3 to 15 psi. Accordingly, you will get some change in flow inside. So accordingly, we'll get level change. This is about a conventional sensor or transmitter based closed loop system. Suppose if you want to make it, if you want to make this site as smart, or otherwise you want to make it as actually smart transmitter based closed loop control system, then we can replace this transmission line with the Wi-Fi. So you can use for some of the wireless transmitters. So you can use wireless transmitter, and you can actually access the data from the remote side, and also you can send signal to the control valve from the remote place. So you'll have a transmitter and a receiver, so through which you can actually operate the system. So this is about the recent smart transmitters. So here I am having ultrasonic type level transmitter. So I am passing ultrasonic waves into the liquid phase. So I am getting output accordingly. So this will be transmitted to the receiver. So this is about smart transmitter operation. So you can actually, when you have more number of transmitters inside the industry, inside the working place, then you need to worry about the data and also data security. All these things comes into the picture. Students can work on the data security and data handling. So these are all the emerging area one can work how to actually go with data security. Suppose assuming that you have 10 transmitters inside a particular field. So you need to actually segregate all these 1,000 or 10 transmitters data, and you need to worry about the data security, all these things. So students can work on the development of, because again the distance is another major factor. So students can work on the distance as well. So you can actually transmit how long we can transmit data. So that is another question mark. So you can work on the data transmission and data handling as well as data security, and some of the development in the sensor side also. So you can actually go with the some sensor technologies. You can actually combine 2 or 3 sensor technologies together to get actually fine data. So that is another area one can think of and work on that. And another part is differential level transmitter. As I mentioned earlier, you can use DPT, so for measuring the pressure. So here I have given 2 pressure. One is high pressure, another is low pressure. So you can actually give the 2 pressure, and change in pressure act as a measurement. this can be transmitted and to the control room or otherwise monitoring place. So from that monitoring place, you can also send signal to the manipulating devices. Suppose if you want to go for a control system. So this is about recent sensors used in the process industries or otherwise automation industries. So here I have given one more sensor, radar level sensor. So radar level sensor, as I already mentioned, this is actually used for continuous level measurement. So which works based on actually the principle we know that TDR, what is that time domain reflectometry, or otherwise it is also called as time of flight. But it is very simple. What is time of flight is actually the time taken to receive the radar signal. So you can actually send radar waves at on the liquid phase and calculate the time taken to reach the receiver. So it get reflected and get collected by receivers. So that time of flight is calculated, and that will be act as a measurement. This can be actually sent through this transmitter. Again, this is actually smart transmitter. You have a local display. You can actually view the readings here as well, and also you can send the signal to the monitoring place, remote place, through this transmission medium. So these are all the recent sensors used in almost all industries. And coming to the applications, we have some more applications like we have discussed about manufacturing and all industry part. So we have few more applications like sensors are mostly used in healthcare, aviation, automotive, and marine. And some of the sensors used in application side. If you take smart city, we have temperature sensor, humidity sensor, and light sensor, velocity sensor, infrared sensor. And if you look at smart health, we have biosensors. So biosensors means which need to be measured the biological parameters, as we have discussed earlier. The glucometer, so which actually senses the glucose oxidation, and through which gives actually the glucose level inside the blood. So similarly, we have accelerometer, pressure sensors, and a gyroscope. And smart home, again, you have temperature, proximity, moisture. And smart agriculture, we have water quality sensor, temperature sensor, humidity, moisture, and position sensors. These are all the sensors used in the application of smart city, smart environment, and smart health, smart home. And the evolution of sensors. So we are actually living in the era of Industry 5.0. So how it actually evolved means Industry 1.0, it late 17 and in 18th century, it is second industrial revolution. Mass production actually happens in Industry 2.0. And Industry 3.0, it is actually automation of production process. So automation comes into the picture in Industry 3.0. And whereas Industry 4.0, smartness in automation, that is Internet of Things, comes into the picture. And now we know that AI plays a major role. So fifth revolution is purely based on AI. That means interaction between man and machine, that is robots. So cooperation between man and machine is actually Industry 5.0. So this is the evolution of Industry 1.0 to Industry 5.0. And coming to the sensor, so now actually sensor, we are actually living in the era of Industry 5.0. Industry 4.0 uses only mechanical type transducers, and later electrical comes into the picture, and electronics also introduced in 3.0. And 4.0, smartness in the sensor introduced and sensor, and now it is application kind of thing, that is 5.0. This is about evolution of sensors. So students can think of this 4.0 and 5.0. So you can actually develop some smart devices, and again, if you develop something with a miniature size and with a very good output, then you'll be hard take in the market. Definitely, you can easily target the audience. So go with some idea pitching team, and you can actually develop something, and also you can go with some kind of cost effectiveness. That is very important. And coming to the IoT enabled sensors, this is about for healthcare industry. So if you look at the readings, the amount of readings possible in a human body, it is actually wireless body area network, WBAN. So you can measure EEG, ECG, and iris, and vocal resonance, and pressure, fingerprint, EMG, MMG. All these things actually shared and transmitted to the monitoring place for actually personalized service, emergency service, and data recording as well as data verification, and for future medication also. And coming to the home appliances, this is actually smart home. So you can use devices for your electrical appliances, and you can use smartness in the security surveillance system, and you can measure all the parameters like moisture, temperature, all those things. So these are all actually in smart home. So coming to the wearables sensors, so we actually come across many wearable devices like smart glasses, smart watch, smart shirt. So everything's smart nowadays. If you take anything, you have actually your walking track. So you can actually you'll get the calories and number of steps taken, and accordingly what is the percentage of calories, and all these things. Now dietitians use this as a tool. So even you will get actually diet sheet for your BMI, body mass index. If you feed the height and weight of your thing, then automatically you will get a diet sheet based on your daily workout. So you'll have the devices for that. So again, there are huge opportunities are awaiting for the young engineers. So you can work on some of the smart device development. And as I mentioned earlier, biometric again another important area. So where you can use all these measurement, the fingerprint, hand, iris, face, DNA, and some of the behavioral also. So your signature, voice, and keystroke. You might have actually seen, or you might have come across in few films as well. So if you watch some of the good Hollywood movies, you will get all these kind of voice recognition and signature kind of thing. And augmented reality, again another important and recent emerging area, AR and VR. So here I have given actually a motor study. You can actually do any kind of study through AR, and it actually plays a major role in healthcare as well. Imaging system, we know that MRI, CT, all these things. Suppose if you want to get some training, you need not go and actually disturb the original system. You take actually AR as a tool through which you get a kind of training, and you can also get kind of different case study analysis and study through which you will be familiar about the device. So in education sector, that is training sector, also AR and VR actually plays a vital role. And doctors nowadays actually using this AR VR, and almost all R&D development divisions actually use this AR VR. Students can think of using AR VR for your project phase. And the smart home, already I have actually given what are all the sensors used in actually. Major is PIR sensor, passive infrared sensor. So passive infrared actually, which actually detects the temperature and based on which gives the output. So how it gives output, this is how actually the sensor looks like. So this is how sensor works. So we'll get output accordingly. So you have a transistor inside. So automatically your light will glow when PIR sensor detects the object. So change in temperature takes place. Accordingly, you will get the output in the outside. So healthcare, you have a lot of sensors like implants, patch, smartwatch, smartphone, all these things. I'll quickly run through the slides because these are all application side. Mobile point of care testing, MPOCT. Some of the wearable patches like smartwatch and these non-invasive type and invasive type. And these are all some of the skin attachable sensors. Stretchable physical sensors. So it can be easily stretchable. It can be placed in the body, which can be used to measure pressure, strain, temperature, and integrated. Also, you can integrate a few physical parameters. And the automation industry, we know that already we have discussed one application. And coming to the automotive industry, now we might have heard about this word ADAS, ADAS, Adaptive Driver Assisting System. So autonomous car and all our recent automotive cars comes with ADAS. ADAS 1.0, ADAS 2.0, likewise you might have definitely heard this word ADAS, Adaptive Driver Assisting System. So you know that nowadays car comes with the autonomous inbuilt. So you can actually use this ADAS. So ADAS means actually if something suddenly appears, obstacles, it takes some decision. Or otherwise some atmospheric condition, that is weather condition varies accordingly, your automatic AC and everything, and the voice recognition nowadays comes into the picture. You will have the fuel and you will have the your tire pressure, everything on your dashboard. So you have pressure sensor, fuel sensor, and you have exhaust gas sensor. You can even calculate the efficiency of your vehicle. So a radar sensor for obstacle reduction, all these things comes in the automotive side. So you can work on all these things. And coming to the last part, I have actually given some of the project ideas for the students. So you can actually go through these ideas and you can develop something and make it as a smarter one. You can actually go with actually some of the security kind of projects, and you can actually locate your area and you can go to the cloud or otherwise some of these servers. So you can actually monitor and do any kind of decision that can be sent to the field as well. And this is actually again a simple application. You can automate this, and you can have the count inside the cattle, and you can sense the count and go to the owner of the cattle how much, and count and all these things, and how active these animals are. All these things can be monitored, and again temperature, all these things, and some of the surveillance system also you can place it here. All these things actually pass with smart cattle system. And coming to the smart irrigation system, you can actually use some sensors to measure the field, and you can they take the data and give it to the your controller, and also monitor through some of the mobile application based or server based or cloud. You can store the data into the cloud for actually global access, and you can operate the motor or pump for the irrigation, smart irrigation system. And garbage monitoring, you can use actually IoT based garbage monitoring. So how much amount of fillings takes place daily. Accordingly, you can actually use GPS system to locate your garbage bin, and you can direct the corporation to collect all these garbage fillings. So this is one of the application you can think of. And another one is you can think of some production line automation. You can actually use this production line where you can actually monitor the machine operations. You can monitor the temperature. You can monitor the lightings. Because lighting, electricity is very important parameter. Suppose if nobody is there, machine is not operating, then automatically light should goes off. So if somebody is there, then it will be get on. So likewise, you can go with some production line automation. And as I indicated earlier, you can actually think of autonomous vehicle and smart drainage for IoT based. These are all some of the project ideas. So you can think of and work on it. That's all from my side. I think I've come to the last slide. So this is about another garbage collection automation. Thank you. So if you have any queries or anything need to be discussed, we can discuss for a few minutes. Yeah, ma'am. So suppose if you have some questions, you can ask. Otherwise, anyway, I'll share the slide to your HOD. You can get the slide and work on some of the project development, or work on the sensor development for your project. Think of some smartness in your project development. Definitely, you will get good appreciation as well as good place in industry. And all the very best. And thank you, sir. Thanks for the opportunity given. And thank you all for your wonderful time. Thank you.
Gratitude transform ordinary plans during nursing, routine into joy and change common opportunity into blessings. I invite Professor Dr. R. Nithin from the department to propose the vote of thanks.
Good afternoon, one and all present here. It is a great pleasure for me to offer a vote of thanks on the wonderful occasion of one-day webinar on recent trends in sensor development. I offer my sincere thanks to our Chairman Sir, Director Sir, and Secretary Ma'am of Muhammad Sadat Trust for the moral support in all aspects. I extend my heartfelt gratitude to our beloved Principal, Dr. B. Nirmalkannan Sir, Vice Principal, Dr. R. Sendilkumar Sir, and Head Planning Ma'am, Dr. E. Dravidachelvi Ma'am, for encouraging and motivating us to conduct this kind of wonderful program. Thank you all. And next, I take the opportunity to thank the intellectual resource person of today's webinar, Dr. K. Vijay Kumar, Professor and Head, Department of Biomedical Engineering, Dr. NGP Institute of Technology, Coimbatore, for readily accepting our invitation. And thank you so much, sir, for your wonderful seminar for our students. And also, I thank our HOD sir, Dr. S. Selvaperumal sir, for his support and guidance. Finally, I thank all our faculty members, non-teaching staff, students, and everyone of Muhammad Sadak Engineering College for their wonderful support and strength towards the successful completion of the program. Thank you all.